Hello everyone. Today we are going to perform 3-point bend test. A 3-point bending test is used to determine the flexural modulus or modulus of elasticity in bending. Flexural modulus is an intensive property which represents tendency of material to resist bending, which is calculated as the ratio of stress to strain in flexural deformation. The flexural modulus defined using the 3-point bend test. Assume a linear stress-strain response. Let me demonstrate it with the help of diagram. As you can see, a specimen in yellow color with rectangular cross-section with width B and depth D, supported at two ends, and if force is applied at the midpoint of the beam gets deflected under this load. This deflection and force is recorded. This figure represents the shear force and bending moment diagram. As we can see from the bending moment diagram, the moment is maximum at the midpoint, due to which the bending stress is maximum at the outer layer of the midpoint of the beam. High flexural strength is essential for the stress bearing restorations when high pressure is exerted on the material or a restoration. As a result, flexural strength also determine the indications for which a material can be used. The more strength the material offers, the more units a restoration can include. In a 3-point bend test, the specimen with rectangular cross-section is used. This specimen is kept on two supports and load is applied at the middle of the specimen. This arrangement is similar to the simply supported beam, which is subjected to a point load at the middle. In this figure, there is compressive stress in the lower fiber and tensile stress is at the upper fiber. The maximum tensile stress will be maximum at the mid of the tension side. Here is the formula given for the calculation of the flexural stress, which is 3FL upon 2BD square, and for flexural strain it is 6DD upon L square, and the flexural modulus of elasticity is L cube M upon 4BD cube, where M is equal to F by D. Sigma F is the stress in the outer fiber at the midpoint, and epsilon F is the strain in the outer surface, and EF is the flexural modulus of elasticity. F is the load at a given point on the load deflection curve, and L is the support span. B is the width of the test beam, and D is the depth of depth or thickness of the specimen, and D is the maximum deflection of the center of the beam, and M is the gradient of the initial straight line portion of the load deflection curve, and R is the radius of the beam. The value of M is the slope of the initial straight line of the load deflection curve. The main advantage of a 3-point flexural test is the ease of specimen preparation and testing. However, this method has also some disadvantages. The results of testing method are sensitive to specimen and loading geometry and the strain rate. With ever increasing demand for high quality and reliable components and materials, flexural tests have become an important test method in both the manufacturing process and research and development to define the material's ability to resist deformation under load. A component's or material flexural strength provides critical insight into the modulus of elasticity in bending, flexural stress, and flexural strain. The increasing popularity of human interface devices such as touchscreen means that every day devices such as cell phones are subjected to many cycles of flexing during normal use. Manufacturers are committed to ensuring products do not fail within their planned lifetime and of guaranteeing performance across a wide range of scenarios. Thank you.